Hello and welcome to the second DICE Community Roadshow webinar. My name is John Favreau. I'm from Trust IT and I am the Director of Communications at the DICE project. So today we'll be talking about some exciting applications of the DICE services in the biomedical community. Before we get started, one quick point about the agenda. In addition to our speakers, we also have some experts in the DICE services with us today, and we're looking forward to answering lots of your questions. But we do ask you to hold your questions for the end, where we have a special Q&A slot, because some of your questions might be answered during the presentations. So without further ado, I would like to present our first speaker, Deborah Testi, who is the DICE project coordinator, and will give us a general introduction to DICE and to our services. Deborah, I'll stop sharing my screen now, and you're free to start. The floor is yours.
Thanks a lot for the introduction, John. So good morning, everybody. As John said, I'm coordinator of the DICE project, and I'm here to give just a quick overview of what is DICE about and which services are part of the project that will be introductory to what Narges will present later in the use of those services in the CompBioMed community. So first of all, DICE is a European funded project under the European Open Science Cloud umbrella. It started 1st of January this year, and it will end in June 2023. And the main objective of the project is to provide data management services and resources to European researchers in general. We have, due to this objective, the service provider are mainly, project partners are mainly service providers, as you can see from this slide. All across Europe. We have also communities involved in the project and some partners helping us with outreach and sustainability of the project. So as I said, the main objective is to provide European Open Science Cloud with data management infrastructure, so to provide generic services to store, find, and access data in a consistent and persistent way. These services are meant to be, as I said, generic, so not tailored to a specific community, so to be able to be used by as many research communities as possible. During the project, we are also aiming to improve some of the services that are part of our portfolio by adding support to sensitive data management, to long-term preservation, and to reach a better connection between data services and computing resources. The services and the behind resources are offered thanks to the EC funding as free for use for services for the duration of the project. So what are the services DICE is offering, covering? This is a quick presentation of a typical research data workflow, from the data generation to the publication of the data after the analysis. And basically DICE is covering all the data related part, so excluding the pre-processing and post-processing of the data. So from the first storage of raw data to their storage during and sharing during the project, up to the full publication of the data to generate a public or other communities. So if we look at the same data structure, data workflow in a pyramid presentation, so what we are covering is the central part of the pyramid, and we are offering services which we normally call personal and project workspace, which are short and mid-term storage to store the data during the project while the project is running. So this is meant for active data. We have data archive services, which are more mid-term storage resources to store data in between or after projects. So it's meant to store non-active data, so data that are not being changed frequently anymore. Then we have policy-based data archive, which is data archive on top of which we can add data management policies like integrity checks or persistent identifiers and other type of policy according to the community needs. Then we have data repository, which are long-term data preservation services for sharing also services with other users, as publicly or with other communities. And then we have data discovery, so making research data findable by other users and communities. Just to mention that most of the services that are part of the DICE portfolio are coming from the EUDAT experience, which has been running already since more probably than 10 years, even more. So these services are being in productions already since quite a long time and are being available to the communities. But new services are being added during the DICE project. Just a quick mention to the capacity that is behind these categories of services. So we are basically offering around 50 petabytes of storage across the different service type. So quite a huge amount of resources are available for all the user communities in Europe. Just another quick specification. Obviously, services can be used independently from each other. So user can just request one service, but they can also be used in combination in an integrated way or integrating services coming from different service providers. And in this, DICE team is obviously happy to support communities to identify the best way to fill in the requirements. As mentioned at the beginning, we have in the project 3 specific community use cases that are making use and piloting and testing the use of the DICE services in their own scientific domain, and CompBioMed is the one that is being presented today immediately after my presentation. As one last point, how you can request access to the DICE services. So first of all, services can be requested anytime. We don't have any calls or deadline for requesting your request. So this can be done when you wish. For most of the services have been already onboarded in the EOSC marketplace and EOSC portal. So you can simply find them there and request them. Obviously, there are, as I said, new services coming up in the next months that are going to be added by the end of the year also into the EOSC marketplace. But you have also other specific requests. You can also contact us via the EUDAT support channel that is present in the EUDAT website. And we will be happy to answer your question. That was my quick introduction to DICE. So I think I can leave the floor to Narges.
So good morning, everyone. Thank you, Deborah, for the nice introduction of the DICE project. Well, I'm Narges Zarabi. I am involved in CompBioMed and DICE, and I'll give you a bit more information about what we are trying to build in CompBioMed to do proper data management and move toward fair data using DICE services. So just a bit of introduction. I'm from SURF Institute, which is a collaborative organization for IT in Dutch education and research. So we host the big HPC infrastructure in the Netherlands to support education and research, the network infrastructure. The picture you see here is the new supercomputer called Snellius, which was launched last month in September. We do have like HPC systems, HPC cloud systems. We also have data services for data management. We have online data services for sync and share, and also offline services such as a data archive based on tape for long-term preservation. And within EOSC and DICE, SURF is also one of the service providers of the EUDAT services. So having that said, it's also good to mention that we are not only hosting big systems or big infrastructure. We also provide consultancy trainings and do a lot of knowledge exchange with our partners and through projects, European projects, but also national projects. What you see here in this orange box is an overview of some of the projects that I was aware of. I think Deborah gave a much a complete overview of the projects in her slide. So we are involved in many projects as well. And having looked into these projects, some of these projects are like contributing to develop services for infrastructure, such as DICE, for example, or EOSC, the European Open Science Cloud. But some other are more on community sites, such as CompBioMed, which is trying to, for the computational biomedicine, or LOFAR, or Odyssey, which is for social scientists. It's a national project. But what I would like to say here is that we contributing to both. So we contributing to developing services, but also contributing to helping and facilitating research communities to use those services. And what I'm more involved is these two projects, the DICE and the CompBioMed project, which I'll give more information about in the coming slides. So what do? I am an advisor of research data management at SURF, and I have been involved in CompBioMed projects since the beginning in 2017 in Work Package 3 on data management and analytics, where I consult everything about data management plan, and infrastructure needed to manage data. But I'm also involved in the DICE project in Work Package 5 for integration with community platforms, and I'm leading the task 5.2 for CompBioMed data platform integration, which I will tell about in the coming slides. DICE was already introduced by Deborah. I have proposed slides to introduce CompBioMed. It is a European Commission Horizon 2020 funded Center of Excellence on the use and development of computational methods for biomedical application. It is a big community with a lot of partners and associate partners, and the community is very diverse with various user groups, as you can see, from academia to industry. So you can think of pharmaceutical companies, but also clinical users and general public. So it is a diverse community with different research pillars, doing research at a molecular dynamics level, all the way in organ level, such as heart or blood flow in the body, all the way to a virtual human. So a lot of interesting research is being done there, which I will show an example later. But it's also important to mention that the community also, as one of the objectives, is moving toward exascale and compute. And the research workflows which are coming up or are being handled are very data intensive and compute intensive. And that's why we needed to have a proper data management solution that could help us handle this type of workflows. And also we wanted to move up, with the whole FAIR principle and keep up with these standards. So if I look into the general data management challenges of research communities, such as efficient data access, data sharing and transfer of the data, intensive data sharing, restricted data sharing, but also preserving research data, making sure that the data that is finished or raw data is being archived in a safe place, but the data is also accessible, can be through usage of PIDs, for example, assigning PIDs to the data, but also possibility to publish the data or metadata, linking the published data to the processed or raw data, and also being able to find and discover data. These are all challenges that I, as a person who was involved in CompBioMed, but also a lot in contact with researchers in CompBioMed, can recognize all. So The main challenges that we have within CompBioMed, as I said, because of the data-intensive workflows and compute-intensive workflows, is how to handle large data sharing, large data transfer, but also restricted data transfer. And we have partners at different locations, so it's a very international projects at different parts of Europe, in the UK, in the Netherlands, in Spain, but also associate partners globally in the US, in different parts of the world. So this has been a challenge that I have seen researchers and research in CompBioMed dealing with. And one of the main challenges within CompBioMed to make data fair, and as I said, it's important for us to keep up with this standard, to be able to make the data findable, accessible, interoperable, and reusable. And one of the main challenges I've seen is a lack of an encompassing solution for publishing data and metadata. And also, let's say, technical awareness of producing such fair data. So we are constantly working together with DICE and also former EOSC partners to try to address this issue through the data, let's say, the CompBioMed data platform that we are trying to build. And also with providing trainings and webinars like this to address the awareness, and also training the community to move toward this fair data. So I would like to show an example of one of the research cases that we have in CompBioMed. Is a very nice research. The slide was sent to me by Yasmin, one of our researchers at Barcelona Supercomputing Center. So what you see here is a research being done using an Alya application. And maybe good to mention that Alya is a simulation code for high performance computational mechanics code to solve multi-scale, multi-physics problems. So what I showed you, the diverse user groups that and the diverse research type that is being done from molecular all the way to human, that's the type of applications that that researchers are working with. It's about in silico human clinical trial for cardiac safety assessment of drugs. So through the use of simulations and using the application, they try to understand why drugs may produce certain effects on some people and not on some others. And can we, for example, produce this observed behavior in using in silico population data? So again, what you see here is like images of the data that is being fed or meshed and fed into the simulation code, and then the output data will be it will be pre-processed and then run in the simulation, and then the output data will be analyzed, and the interesting questions you see here will be answered through the use of synthetic data and simulation data. So again, here you see how this in silico trial was able to reproduce the potential arithmetic effect of the combined use of very difficult words. I'm not an expert on these terms, but again, I wanted to show you the type of research that is being done. So here you see, for example, how the whole heart is being simulated, and as you see here, the researcher is dealing with 27 terabytes of data. And this is a data that maybe for us as a service provider, as an HPC center, might not be that big, but for a single researcher in a research institute, this is a lot. This is a huge amount of storage. And if this data needs to be transferred to another center or shared with another researcher, you can imagine what the researcher will face to do this. And well, it's almost impossible because if they want to send it through internet, or it's almost, very difficult, let's say, for them. So we have had cases, for example, that data was produced in a lab, and then was stored somewhere there locally, and then these researchers have to bring hard drives to copy the data and take it physically to the HPC center where they were analyzing this data. These type of requests was why it triggered that we need to have a proper data management place, or make use of the services that is being developed through projects such as EOSC and EUDAT and DICE. Of course, we don't want to create the wheel ourselves. So to make use of those services to help out the researchers. So the research use case, as I just showed you, that was very, let's say, at the research question. But what we tried to do together with those researchers was to understand those steps and sort of translate it into, let's say, technical steps that they need to do to process their data and get the output data they need. So as you can see, in total 4 steps we come up with. So the raw data is being collected, as I said, in a lab, in this case, for example, in ESRF in France, and the data is being stored locally there on tapes. And then with means of hard disks or whatever difficult way, this data has been transferred to the Barcelona Supercomputing Center for performing high performance computing on the data. So the data is being pre-processed at the BSC and includes a lot of manual or automated steps to process or pre-process the imagings and make segmentation and meshing. And then this data is at the Barcelona Supercomputing Center, but these researchers at BSC also work with the researchers in the UK, in UCL, for example. And this Alya application that is used to do this analysis is also installed in, for example, SURF, which is another HPC partner in the project. So you can imagine that if researcher at Barcelona wants to share data with another researcher, or just wants to scale up the compute power they have, and they needed to transfer their data there, they needed a proper solution in place. So that's why we put step 3, to be able to replicate data, produce replicas of data in other HPC centers, such as SURF, for example. This would, first of all, we'll make sure that there are replicas of data available. So if something happens to the data in Barcelona, there is still a replica in other parts, but also facilitates sharing of the data, transfer of the data. And at SURF, for example, we have our the archiving facility, which ensures long-term preservation. And then once the data is replicated, of course, a lot of interesting things can be done. You can think of, for example, resilience compute applications or workflows. That if a simulation somewhere fails, it can be continued running somewhere else. But also, as I said, just for the sake of having replicas of the data and making sure that the data is safe. So that was basically translating that use case into more technical steps that need to be done. I would also like to mention that during the CompBioMed 1, CompBioMed projects had different phases. We started with CompBioMed 1, but now we are in CompBioMed 2. So we did a pilot to see if things are possible, and tried to deploy the B2 Safe service in 2 centers. Well, SURF already was providing B2 Safe as a service, so we tried to deploy this at EPCC and BSC, the other 2 HPC centers within CompBioMed, with the aim to have safe data replication and facilitate large data transfer and bringing data close to compute and scale up the compute power. And what we achieved was that we did deploy these services, the B2 Safe service, in these centers, and we did a federation. So we tested the federation and tested the performance of the transfers, etc. So that's something that we did as a pilot in CompBioMed 1. But within CompBioMed 2, we decided to, go further, let's say, because data management is not only about facilitating large data transfer, which our researchers originally requested us, but it's also about making sure that the data that is being produced in this community can be made findable and accessible for the larger community. So we thought of two different workflows. We called the data replication workflow, which facilitates large data transfer, data preservation, and brings data close to compute, what we originally tried to achieve in that pilot, but also a data publication workflow, which the idea is to have a data repository that we can publish large data, because, as I said, the data being produced in CompBioMed is quite large, or at least the metadata, so to be published. And also come up with a metadata schema for CompBioMed community, because right now it's like we have different type of research and different types of metadata, but no generic metadata schema that could cover all. So within the CompBioMed and DICE collaboration, we try to implement these two workflows. The partners, the direct partners involved from CompBioMed side are UCL, which is actually leading the CompBioMed project, and we are very happy to have them on board, but also BSC, the Barcelona Supercomputing, and SURF. And the services we have come to conclusion that will be needed to implement these workflows were the B2Share, the data repository, the B2Handle for making persistent identifiers, and the B2Safe for replicating data. Again, this is an overview of the services that we are gonna use, and the estimation of the resources that needed for each center. And so I put it two slides to very quick describe what these services are, but I think Deborah already provided a good overview of these. But just to mention that the B2Safe service is a service that is developed by EUDAT, and it's based on IROTS, which is a middleware that facilitates defining data management, data policies, let's say, and also making replicas of data in different centers. And the B2Share, which is the data repository, and we are going to deploy an instance of the B2Share at UCL, so that it can be connected into as many storage as we want, let's say, in the backend, so that data and metadata can be published. There's also the community instance of B2Share, which CompBioMed, we have already created a community in there. We are working out the metadata schema yet, but that's, let's say, a limited amount of data can be published. So that's why we decided to deploy our own instance of B2Share to facilitate also publishing large data and also raw data. So this is the interesting slide, I would say. It shows the data replication and publication workflow. I put them both in one slide. So as you see here, we have the three partners involved in this collaboration. We have UCL, in the UK, we have SURF in the Netherlands, and we have BSC in Spain. And the idea is that an instance of B2Safe will be deployed in all, SURF and BSC already have the B2Safe, but we are working very hard with UCL to also deploy their own instance of B2Safe. And the reason for that is a lot of research and a lot of data is being produced in the UK. And that's why in contact with the IT department at UCL, we have come to conclusion that it's good to have this service deployed and federated with the other sites. And it's also good to mention that the IT department at UCL is involved in this. So also sustainability of the whole thing. This is very good because it's not only done for the project, but really the data department or the IT department at UCL is involved. So any further maintenance or of the service could be handled by them even after the project finishes. As I said, we are going to deploy the B2Safe instance at UCL and make a federation between all the sites. So achieve a federated network of B2Safe endpoints so that data or large data can easily be replicated among these sites. And then using the B2Share data repository for publishing data. So again, a dedicated instance of B2Share will be deployed at UCL for this to publish data. It's also good to mention that at SURF, we also do have the SURF data repository, which is very similar to the B2Share repository, and it's meant for publishing large data. So we have mentioned in our plan that if, for example, it is data that will have to remain in Europe, or we can use the data repository at SURF for this purpose. And this is already a running service, and well, we can just make some arrangements and use it for publishing data if needed. So we have made a work plan for all this and described the technical tasks. Well, this is too much text, but we have even a more detailed tasks described in our plan for this. But just to mention that we have a plan with a timeline. Hopefully we can achieve everything or implement and deploy everything on time, let's say according to our plan. We have already started, as I said, with deploying and configuration of these services, especially at UCL, which is well, a bit behind, let's say, and need to configure these things from scratch. But we are getting great support from technical support in deploying these services through the collaboration of CompBioMed and DICE. So our partners at UCL are in contact with, for example, the B2Safe core team or B2Share for any technical support that is needed to deploy these services. So that's really great. This is also how we see it as, let's say, the CompBioMed data platform. So basically the data publication and data replication workflows builds up this data, CompBioMed data platform, let's say. And this is how we see it being extended or as a future concept, because what I showed you earlier was these three centers, the SURF, UCL, and BSc. So within the collaboration, we have kept it a bit small to make sure we achieve what we are planning to do. But as a future concept, we would like to extend this platform to other HPC centers and even medical or research centers within the community, because as I showed you earlier, a lot of this data is being produced, for example, in medical or research institutes or labs, which could be using this platform easily brought into close to compute and high performance facilities, or even shared with others. So this is how we see it growing, let's say. So we have LRZ in Germany, and we have EPCC also in the UK, other HPC centers in CompBioMed. So let's say once we achieve this core flow of federating these centers, we would like to proceed with federating with those. I must say that federation between SURF and LRZ is already in place, thanks to a collaboration we had with another project called Nexus, CompBioMed and Nexus, but also like federation with EPCC. We did a pilot, but still, right resources need to be made available at different centers so that we can make sure that this federation that we have is something that can be production ready. So this is basically how we see it as a future concept, that all the HPC centers in the community are federated, so large data transfer can be facilitated, but also publishing data. So we are monitoring the integration of B2Safe, B2Share within the EUDAT and DICE to see how that develops itself, and would like to make sure that every data that lands on these B2Safe endpoints can also be easily published in one of our publication sites. So basically that's it. I'm not sure how I'm doing with time, but if there is any questions, I think at the Q&A you can ask, or I hope this has been clear. Again, if there is any questions, I would be happy to answer in the Q&A section. I'll hand over to John.
Thanks very much. You're actually perfectly in time. So, as Nargis said, we are now in the Q&A session, and we look forward to a nice discussion. I will be co-moderating the session with my DICE colleague, Nadia Tonello of the Barcelona Computing Center, who is the Director of Community Outreach in DICE.
John, there is a comment and a question by Abdurrahman, and it says that it's a perfect use case for secure B2 share. So I don't know if Nargis wants to tell something from the BSc. I want to remark that this is exactly what it's a right comment, and also says that since in this use case is not meant for handling sensitive data, having a secure B2 share is for sure a useful thing to think of for the future. So if Nargis wants to comment.
Yeah, no, I think that's a very interesting point, and I think Abdurrahman and I in another session have discussed some things, but yeah, maybe I'm throwing back questions that because, well, I know B2 share, but I know exactly what the status of let's say secure B2 share or B2 share for sensitive data is. Is it, let's say, running a service at production, let's say, that can be deployed by our partners, let's say, because we are now looking into deploying the B2 share instance from the GitHub, and I see that you have sent the GitHub link, so that's great. But I think we need to discuss this further to see, okay, what is it that we achieve or gain with deploying a secure B2 share, and because right now for me it's not 100% clear what the differences are and what would be the added value. Of course, it's for sensitive data, but again, a lot of data within the community are just, let's say, synthetic data or data that are anonymized or processed as much that, well, can still, or metadata can still be published in a normal repository. We have been in contact with a couple of researchers at UVA, but also in the UK, to understand their data and metadata and the sensitivity of their data. So as I said, we are defining this metadata schema. So I have got an understanding of how their data is with respect to sensitivity. But I think it's good if we have a follow-up discussion to see what the secure B2 share really means and how it can serve the needs of publishing those data. So very great comments, but I think we need to discuss this further.
Yeah, I can describe it very, very quickly. First, following your guides, John, my name is Abdurrahman Azab. I work at the University of Oslo Center of IT. I work at the Nordic Infrastructure Collaboration Executive Team as a Senior Advisor, and also I'm part of the LUMI User Support Team, the pre-access scale system. So for secure B2Share, very brief, it has the same interface as B2Share, but instead of having the chance of sharing non-sensitive data sets on the actual B2Share server, it gives you an additional functionality of sharing only the metadata of the sensitive data sets, where you have your actual data sets stored in a secure storage behind your firewall. So one B2Share server in this case can hold information about both. If you have non-sensitive data, you store them in the regular traditional B2Share way. And the same server can also point to sensitive data. So you can use it for both. I understand in your use case, you will have some data which are sensitive, some data which are not sensitive. So one secure B2Share server can serve for both. And of course, we can discuss more on the technical implementation. There is one secure B2Share server at the University of Oslo, and there will be another one at CSC soon. Yeah.
Now, very interesting. And so let's say if we, so if I understand correct, then at UCL, because we want to publish large data, right? And this was one of the comments we also CompBioMed got from the review by the European Commission, because this does not fit into the community instance of B2Share. That's why we are deploying our own instance. So does that mean that an own instance of the secure B2Safe should be deployed as well?
The secure B2Share is completely compatible with the B2Share. So the main developers that are at CSC who are also maintaining B2Share. So we are not breaking any of the actual rules there. So whatever B2Share can make and can do and can be compatible with, secure B2Share will be also the same. It just have this additional functionality. So it is not like working in any different way.
Yeah, no, that's very interesting to know. I think we would, it would be good if we do a follow-up on this. And yeah, so thank you for your comment.
Yeah, thanks. I actually had a question regarding the HPC part. So maybe I don't remember if we talked about this before, but we got this pre-exascale system LUMI and phase 1 of the HPC CPU partition already running. You mentioned something about computational intensive and data intensive processes. And maybe you can elaborate about this. Would this be something to fit into large HPC systems like LUMI? Because in these systems, we are not interested in small jobs that don't scale. Those can run on national infrastructures that are not that expensive or not that big. But we are interested in jobs that can scale, that can use the system, and LUMI will be like a good fit and need for them. So what about your types of workloads in CompBioMed?
Well, I would say it's definitely interesting if it supports exascale or pre-exascale. That's I think something that would be definitely of interest to CompBioMed, because again, a lot of efforts is being done to move toward that direction. Well, I must say I'm more involved in the data part, let's say, so not very much expert in the compute part. But I know that, my colleague Marco Verdicchio, which is also the technical manager of CompBioMed, has been in contact with maybe your team or people from DICE who are involved in or are doing this type of exascale. So I'm certain that this is of interest, but I'm afraid I cannot comment much on the compute part. So I'm not sure if Marco is present in the attendees, but yeah, that's something that is certainly of interest. let's say. And I know that there are discussions regarding that. Maybe even you were involved in one of those meetings, but yeah, that's as much as I can say right now. But I can get back to you, discuss this with Marco, and get back to you on this topic.
Yeah, great that it can be a follow-up.
Great. So from the computing point of view, I am at BSc, and we have just seen Alya simulations. So the data we were talking about in this use case, specific use case, are running at BSc, but in principle, it is running already in a supercomputer in Mare Nostrum 4. It will be already prepared for the exascale, so or the pre-exascale at least. So having a compatible way of running large simulations for this community in many centers, not only BSc of praise centers or like LUMI or Mare Nostrum 5 when it will arrive, it will be an added value that for sure it will be taken into account for the future developments. So I don't know if Chris wants to say something also related to this, since he's from CSC.
Yeah, it's Abdulrahman had said the possibility, so it is possible to make use of LUMI. And the other point too was about secure B2Share. So if we need to move forward with that, so we should talk about it with the CompBioMed community and then see how to help in creating a reasonable B2Share that will also be possible to publish secure sensitive data.
Yeah, great. I forgot that we have Nadia and Chris to address this question, so thanks.
Great. Any more questions from the floor? So, so what I want to do is I want to thank everybody here for having participated in this session. This is only one of several that we are having. This is the first actual community roadshow with a special community that we have had, and there are more to come. We will have one on astrophysics community, one on the environmental monitoring community, and we expect several more to happen. So I hope you will watch this space to follow more DICE webinars as they come. There will also be some specialized webinars coming up on the DICE services themselves, taking deep dives into special aspects of the DICE services. For example, next month we plan to have one on the entire virtual access mechanism that is used to finance for you, free of charge, during the entire DICE project, the access to the DICE services. So towards the end of November, watch this space, as I said, in order to participate also in that webinar. So there will be a lot of information coming up for you and your community to decide how to make use of these DICE services. So once again, thank you to you, all of you participants. Thank you to all of our speakers in particular, Nargis in particular, and Deborah, and all of the members of the DICE team who have helped out to give us information about what was said during the webinar. And I look forward to seeing you at the next time around.